Hello, this is Fazlurrahman Belfry and I'm going to present our work on fake news spreaders profiling using a game of various types and shape-based feature selection. And this work is an extension of our previous work on fake news spreaders profiling that we try to improve them using feature selection and applying different types of engrams. So first let's see what we have in this slide. I'll give a brief description of task and then motivation, and then we will talk about data set we use in this task. We'll continue with the existing works on literature and our proposed methodology. Finally, we'll discuss the result and comparison. So now I'm going to give a brief description and motivation of tasks. So the velocity in which the information are being shared has increased day by day, and it's getting wider audience because internet is accessible in every point of world. So and also the anatomy of social media and the attribute of being unknown in social media made social media platform much more popular, especially among younger generation. So most of users in social media use it for fun, sharing useful information, sharing their times, their stories, and also promoting their business even. But this freedom and the attribute of being unknown in social media give and provide an opportunity for content polluter who wants to share fake news and false information in social media. The reason why these people are sharing fake news can be for fun or targeting some community or different reasons that need to be explored in a separate work. So we are not going to more detail about international terms. It's already given in our paper and also our previous works. So, but the thing is, when we are using human beings to identify fake news and profiling them on social media is something like far from reality due to huge amount of data and characteristics of social media text. So this gives rise to using computational method for fake news detection, profiling, and the spread of them. And such methods are doing fairly good in recent works. And also nowadays, a state-of-art deep learning model such as long short-term memory and LSTM and transformers are proving their effectiveness in many areas, including natural language processing. However, still traditional machine learning with good feature engineering can perform well, or even in some cases even outperform the deep learning model and transformers. So many machine learning and deep learning models were proposed by researchers for profiling tasks such as human bot profiling, gender identification, hate speech profiling, fake news profiling in pan-share tasks that Lincoln have given here. So, but this task focuses on identifying and profiling fake news spreaders who share fake news on their tweets, and the task was available in English and Spanish. So based on tweets shared by a user, a label will be assigned to a tweet spreader, like it is a fake news spreader or not a fake news spreader. So in share tasks, in previous work that we also participated in share tasks, we provided train and test data that we are using them in this paper as well, and also in previous works, in profiling works like both gender and fake news spreader or even hate speech spreader tasks, the effectiveness of machine learning model and on top of them model which deploy engrams are proven whenever they are much more better than machine learning and deep learning and transfer learning models. So also in overview papers of those share tasks, it is reported that char and word engrams in combination of stylistic, personality, and emotion-based features were commonly used by share task participants. Furthermore, most of participants consider all extracted features overlooking in feature selection to design model for shared tasks, but still they often do the result. So the main thing is they are not usually they are not applying in feature selection, or and also they are usually using word and chat in GAM. In case of different engrams, they are only using chat and word engram. So we are going to extend this machine learning model and try to check the effectiveness of some feature selections and different type of feature and generating engram out of them in this work. Well, about data set, we are using the data set provided by profiling fake news spreaders on Twitter, ShareTest and PAN 2020. I have given the link, so it consists of tweets in English and Spanish, and it's highly balanced, as you can see in the table for both languages. I think it includes 300 authors for training, that for each author 100 tweets is there. So based on the tweets, we are going to find out a user is a fake news spreader, or same thing with this set, but the number of authors are 200, but both data sets have very same and balanced distribution. So as I said, there are various different machine learning and deep learning models submitted to the shared test, but among them I tried to first in this table bring what model that are using chat and word engram combined with other feature types that are also getting good feature, but over some of them that are getting much better accuracy are given in last slide to compare with our proposed method. They are also using word and chat engrams in different combinations. So here, as we can see, different kind of features are combined with engrams like word embeddings, mentions, hashtags, retweets, emojis. In some only word and chat engram. In our previous work, which is third one in Shashika, we use engrams and combine with dot vectors using linear SVM and logistic regression. Also, another work of us is Spinoza, that we're using word and chat engram again. In other words, you can see word and chat engram combined with different features are very famous and very common used. And classifier uses neural network and machine learning, which are getting also some reasonable and promising results that we can see for English and Spanish here. But they are not the best one. Best one we kept in the last final slide to compare with our best models. So in table 2, in previous table we given a model based on engrams and machine learning, but in this table we are giving different features and based on transfer learning or transformers and deep learning models that you can see that are based on RNN, CNN, LSTM, bi-LSTM, combination of them, or Electra and BERT based model. So they are using pre-trained language model usually, or word-to-vec, or the frame natural net language model and syntax encoders. They are giving good results, but still, if you compare with previous slides, they are a little less than, because usually all are above 70, 73, above 72, but here we can see some are 70, some 68. Still are close with some margin, but because they are the best out of around 60 teams, these are best transformer or deep learning based models. So let's start talking about our own methodology, what we have proposed here. So our methodology consists of 3 main phases, which is feature extraction, feature selection, and model construction. Feature extraction phase consists of 2 main modules, which is feature extractor and engram generator, as you can see here. Feature extractor is responsible for extracting various primary features such as char words, char sequence, syllable. So we are not just working on words and char, we are working on char sequence and syllables as well to generate subwords. Chars and words feature are obtained using traditional splitting char sequence for child sequence, we use analytical library and everygram function. And for syllable, we are using index syllabifier, which is employed to extract syllable from text. In spite of index syllabifier, it's not full, it doesn't have full support for Spanish, but still we wanted to check how it's going to work and the performance, but it has full support of English. So in Ngram generator, we will accept the list of primary features like such what we define: characters, words, syllable, and child sequences, and it will give also, it will receive also the range of engrams as input along with list of characters or elements, and will produce the engrams of the corresponding primary feature in the given range. So it will be a list of elements and a range of engrams, and it will give the engram of corresponding primary features. Also, we tried the syntactic engrams, and we are extracting them using SNgram extractor, which provides full support for both language, English and Spanish. So text is a high dimensional in nature, and the engrams feature in different range increase the dimension further. So to reduce the dimension, experiments we conducted with different values of frequent engram feature, starting from 10,000 to 100,000, and also all features we tried. I mean, instead of doing feature selection in all feature, we selected the top frequent features. I will give the detail of all feature selection and feature reduction in each step later. So we didn't do feature selection for all features. We have done feature selection or main feature selection on top frequent features. So based on that, we selected 30,000 most frequent engrams. Then we consider them for each primary feature, and then feature are transformed to vectors using TF-IDF vectorizer. So the structure feature extraction model is shown here. So as you can see, only top 30,000 most frequent engram out of each primary feature are used and sent for feature selection. So here you can see the workflow of feature selection. I give a brief explanation of this also. SHAPE, the state-of-art method for model agnostic interpretation, is used as a feature selection mechanism, as this approach is based on the need for model interpretation that has been growing the past years. This approach assigns a shape value for each feature in the feature set, which represents the contribution of that feature for model predictions. So these shape values encode the importance of a feature in predicting the model output, which in turn can be used to order the features based on their importance. This selecting a subset of D feature based on shape values means selecting the top D feature based on their value of importance and based on their contribute to model prediction. As shape is integrated into three boosting frameworks such as XGB, it is trained and used as a classifier to create shape explainer to calculate shapely values for all the 30,000 frequent primary features that we already selected in the feature extraction part. So these are the most frequent features. So as the performance of the final model depends on performance of XGB classifier. So the higher result for XGB classifier as a feature explainer results in betterment of selecting relevant features as in feature selection step, and consequently higher performance for the final model. So after performing experiments with various values to select top D features based on shape values, we decided to select 15,000 engrams for each primary feature engram. So just look at the workflow. First, we generated all features. We selected 30,000 most frequent features, and out of them, using this feature selection, only 15,000 feature from each primary area set. Actually, we set it like this, some fixed value, because we wanted to keep our model simple, and also to avoid use much RAM and this thing, because we have some restriction on this. As our presentation time is running out, I'll share this slide that you can go through this, and also you can check in our paper. Here we have given the range of each feature, the total number of features generated, and number of frequent features selected, and number of final selected features that we have used for training. So I don't waste much time here, that you can check in our paper and slides. I'll go directly to model construction. So we use the 4 traditional machine learning classifier, some basic one, linear, SVM, RBF, logistic regression, and random forest classifier. So an efficient way to evaluate the effect of various features is to train the classifier with different features and check their performance. So all the classifiers that are used here are with default parameters, except for random forest classifier, where the number of estimator is set to 10,000, and more detail in the paper is there. So we pre-process our data. So after pre-processing, the twist various primary features are extracted and considered individually, as well as in 6 different combinations by stacking 2 or 3 primary feature sets. So we use these feature sets individually, chaining them separately, chaining sequence separately, reducing separately, and also we combine them, which we have given different combinations with results in next slides. So in pre-processing, all non-alphabetic characters are removed from the given text. Remaining text is converted to lowercase. So non-alphabetic characters such as emojis that contain valuable information are removed at the cost of simplicity of the model. So we wanted to keep a simple model. We understand that having emojis converted to text can improve the accuracy, but we wanted to keep our model simple as a basic pre-processing use. So the 6 larger feature sets are a combination of char and word-n-gram, char sequence and word-n-gram, syllable and word-n-gram, char and syllable engrams, word and syntactic engram, char, syllables and word engrams, and different combinations that are given in paper also. So there can be more combination of primary features, but in this study only this combination are used due to hardware and RAM limitation, and also to keep our feature sets simple. Maximum of 3 feature sets are combined. So shape-based feature selection is then applied for 30,000 most frequent features, as I said, and then 15,000 features from each category is used, and then we give 2 classifiers. So in table 5, 6, 7 to table I think 15, we have result for each feature set and their combination, that I'm not going to explain because we are running out of time. So you can check in slides. In our paper you can see most of the results that we are obtaining are among 5 best results in the competition. If we compare, we'll give a comparison in final slide. Also in using word engrams, syntactic engrams, the combination, everything is there. So I'll come to comparison of with all models, top model in task. Here you can see that best result for English is obtained by char sequences, which is dark blue, some in middle you can see. But for Spanish we couldn't improve the result, and Pizarro, the reference number 7, got best result, but still all other models are among best models. All other results are among the best. So if you want to give a better comparison, you can see our proposed model in English we improved and we got the best result among all. But in Spanish we obtain a better result compared to baseline, which is Simanto, but still there is two models that are outperforming our model in Spanish, but if you consider the average, we obtain best result among all the teams in competitions. So this shows the effectiveness of a very simple models, and when we are adding a good feature engineering and selecting top features and also some feature selection. So this also proved that alongside with going forward with new models, a neural network based model, a still machine learning model can be used if we empower them with better feature selection or feature engineering part. So I skipped some of the slides, but if you have any question, you can contact us through our mail, which I have given in last slide, and also if any other question, you may contact us. Thank you.